All right, this is your lecture video for section 5.1. We're talking about ratios. So the first few screens are going to talk to you about the specifics of it. A ratio compares two quantities. You can compare two numbers such as 8 and 4, or two measurements that have the same type of units such as 3 days and 12 days. The thing that's important to remember about ratios is that they have to have the same units. The unlike units, or units that are not the same, will show up in our next section, which is called rates. Ratios can help you see important relationships. For example, the ratio of your monthly expenses to your monthly income is 10 to 9. So when you're spending, this means that you are spending $10 for every $9 that you make or that you earn, and you're just going to keep going deeper and deeper into debt. So it is helpful to use ratios to evaluate two quantities. All right, so this first part says to write a ratio. And the ratio is $7 to $3. It can be written in one of these three ways. And so I want you to see that this is one way, and this over here is another way. And notice that the TO is what the red in each of these mean. So on the far left it says 7 to 3. The middle one says 7 to 3. And the last one says 7 to 3. The 2 that we're saying is the TO, not a quantity, so it's just the TO word. And the most common one that we will be using in this class is this fraction form. Now this is not 7/3, okay? We're not actually calling it by a fraction name, but we're actually, in a ratio, we're comparing two quantities. So this is 7 to 3, the TO word as your fraction bar, how we read that. All right, so for this one, it says that we're writing a ratio as a fraction. So remember I told you that was the most common way to see this. The way that you need to know how to set this up is that the order is important. So when you're reading a ratio, the first number that you come to, or the first item that is mentioned, is your numerator, goes on top. And the second quantity that you come to is the denominator. So for the example here, the ratio of 5 to 12 is written 5 to 12. The first one we came to was a numerator, the second one we came to became a denominator on the bottom, and so this is our answer. A room measures 14 feet long, 11 feet wide, and 15 feet high. So this little given information is given to you for the next two problems, this one and one other. But the first one says to write a ratio of length to width. So first of all, I look for length and I look for width. So long and wide would be the length and width. Length came first, so that's where I'm going to write my 14 feet over the 11 feet wide is the width, and it came second when I was reading. See, 1, 2 here in the words. Notice that the feet are the same label, so I'm going to cancel those out. And now I have 14 to 11. And if 14 to 11 could simplify, meaning that I could divide both of them by the same number, then I would. But I cannot, so I'm going to leave this as 14 to 11. This never, ever, ever becomes 1 and 3/11. This does not become a mixed number because it's not a fraction, so it cannot be turned into a mixed number. We're still comparing two measurements or two quantities, which is 14 and 11. All right, the next one says width to height. So here's our width, came first. So our width of 11 feet goes on top over our height that came second, and our height is 15 feet. Here again, we have matching matching labels, right? They're both feet, so I mark those out, and I have 11 over 15. Once again, if I could simplify this 11 over 15, I would, but remember, it never becomes a mixed number when the numerator is bigger. So this is 11 to 15, final answer. All right, this one's a little bit longer. But we've got to kind of decode what's important. 60 days of sun to 20 days of rain. So here's our two that we're comparing. So we have 60 days to 20 days. This is helpful, but it's not really relevant. But the 60 days and the 20 days is our comparison. My labels match, so I mark them out, and so I have 60 to 20. And remember, these are not fractions. So this is not 20 goes into 60, how many times evenly, and I get a final answer of whole number of 3. We're still comparing two separate quantities. I can simplify this, but I have to leave it as a numerator and a denominator. So yes, they both are divisible by 20, and I end up with 3 to 1. So for every 3 days of sun, we would get 1 day of rain according to this ratio. So you have to leave the 3 to the 1 so we know what we're actually talking about and comparing. All right, 50 ounces of medicine to 120 ounces of water. Again, yes, this is a mixture, right? We're talking about medicine. But in this case, we're not actually in need of these mixture labels as much as we are really trying to break this down and cancel out what we don't need. So I have 50 ounces because it came first, and 120 on the bottom because it came second. I'm going to cancel my labels, so I have 50 to 120. Okay, and we're trying to see here if 50 and 120 can simplify, and it looks like they're both divisible by 10. And so I end up with 5 over what? 12. So 5 to 12. So for 5 ounces of medicine, we need 12 ounces of water. So it's a 5 to 12 ratio. 15 people in a large van at 2. Here's my comparison. 6 people in a small van. So I have 15 people and I have 6 people. I'm going to mark out my labels, and I have 15 to 6. They are both divisible by 3. And I end up with 5 to 2 is my comparison. All right, this one is the last of the comparisons. And then we're going to move into some that need to be converted into matching labels or matching, quantities, I guess, or labels, yeah. Oh, sorry, it's been a long day. All right, so first thing that I want to do is I want to write this out. And so the first thing that I see is 3 1/4, 2, 1 1/2, right? I wrote it in fraction form. But this is not very user-friendly, right? I want to change this into something that's useful or helpful to me to make it make more sense. So I know how to use this little backwards C method that we've learned in class. And so 4 times 3 is 12, 12 plus 1 is 13, so I have 13 over the existing denominator that I brought right over. And so then here's my fraction bar. I'm going to do the same thing on the bottom over here. 2 times 1 is 2, plus 1 is 3 over 2, and I brought that denominator straight over. Remember that anytime that you see an actual bar like this, it means divide. And so we're going to write this problem out to try to simplify these two fractions a little bit more. So I have 13 over 4 divided by 3 over 2. So keep it, change it, flip it. You are not allowed to simplify anything until it becomes a multiplication problem. And so here is my flip it. Here I can see that they're both divisible by 2 in this diagonal. And so 2 goes into 4 2 times, 2 goes into 2 1 time, and I end up with 13 times 1 over 2 times 3. And so I end up with 13 over 6. So this messy original problem here, this ratio, becomes a ratio comparison of 13 to 6. And so this would be our final answer. All right, this next example, you'll notice, has not matching labels. So 2 feet and 30 inches. Feet and inches are not the same. They don't get to be canceled out. But feet and inches are in the same family, meaning I can change one of them into the other measurement, and then we can cancel them out. So for example, I'm going to go ahead and set this up. So I have 2 feet over 30 inches. Okay, we're always going to the smaller measurements, so we're going from feet to inches. So over here I need to have inches and inches. And now realize that the 30 is not changing, it's already inches, so I'm actually changing 2 feet into 30 inches. So what I need to know is how many inches in a foot, right? 12 inches in 1 foot, and so I'm going to multiply 12 times 2 because I have 2 feet. And so here's my 12 times 2 feet, which equals 24 inches. So my 24 goes on top up here. So now that I have matching labels, the inches go away and I have 24 to 30. And 24 to 30 is simplified by dividing by 6 on top and bottom. And so I find a simplified ratio of 4 to 5. Final answer. Let's do one more of those, because there are some of these on your pre and post test. The first thing is we want to make sure that we set this up correctly, reading from left to right. So the first thing that I come to is the 28 days over the 3 weeks. Remember, we're going to the smaller units. So smaller units are days. So that means we're going to have days on top and days on bottom. My handwriting's terrible. All right, so how many days are in 1 week? 7 days in 1 week. And how many weeks do we have? 3 weeks. So 7 times 3 is 21. And so here I have 21. Here I know that my labels match, so I cancel out my days and days, and I brought over my 28 to 21. Here I know that they are both divisible by 7, right? A whole week is 7 days. And so on top I end up with 4, and on bottom I end up with 3, and so this comparison is 4 to 3. Final answer. The one thing that I want to mention to you that is not on this screen, that is printed in your lecture notes, is the very last page, page 5 at the very bottom. It has conversions. So some of these that we did in the last 2 examples, you'll need to know, like the length conversions of inches to feet, feet to yards, feet to a mile possibly. There's weight measurement conversions from ounces to pounds, pounds to a ton. Capacity, which is cups and pints, pints to quarts, quarts to gallons. And then time, of course, is a very popular one. So seconds to minutes, minutes to hour, hours to days, and then days to a week. So those conversions can be found on the last page of your lecture notes for section 5.1.